Now, whether or not you actually watch the quantum physics lecture series where I go in detail about what matter is and how it works and what are the particles which actually constitute matter, you should have a general understanding that atoms are made of smaller things, which are electrons, protons, and neutrons, and then those things are also made of smaller things even, or elemental particles, which make the universe tick, and that the universe have these fundamental forces which put everything in motion and explain everything that happens. And that many advances have been done in the 20th century for us to understand this better. You should also have a general understanding about the classic 3 states of matter, as well as the idea that there are more than 3 states of matter. In fact, there are many states of matter, or matter phases. And you'd have to at least understand the major 3, plus the idea of plasma, which is an ionized gas. You also should understand that under certain conditions, matter will start acting different or as a solid unit. And all those particles or constituent parts or atoms will act like one big block of matter, what we call condensates or supercooled matter. And you should understand that that's also different states of matter. So you have plasma as the superheated matter, and you have supercooled matter. An example of that is condensates, like the Bose condensate or the fermionic condensates. Please watch the other video where I talk about the states of matter so you can actually review these concepts if you do not understand them. But what you're going to need for the purpose of earth-based science is understand that condensates are states of matter which are really cold, plasma states of matter when it's really hot. Condensates, the matter acts like, all the particles act like one united unit, all in the same quantum state. And then plasma are states where the matter is superheated and the electrons are no longer flowing around the nucleus, and matter starts dividing into its smallest subsequent parts. Now, another thing that you need to know about matter is the idea of physical versus chemical properties. Now, a lot of people get confused about this, and I think I found over the years that the best way to teach it is by examples. And honestly, the only difference between physical and chemical properties is it's got a qualitative way to classify matter. So physical properties are anything about the matter that has to do with what it is, what it looks like, what it smells like, what it acts like. But chemical properties are more like how matter reacts with other matter. So physical properties are intrinsic to that kind of matter, while chemical properties have more to do of how that matter relates to other matter. So the best example of thinking about that is that a physical property of an element will be, as an analogy, the way the element looks like. So if you have a couple, they're attracted to each other because of the way they look like sometimes, because of the way they dress, because of the way they smell, because of all those things, because of the way they run, how good they are at doing math, how good they are at art, how good they are at singing. These are physical properties, characteristics which can be measurable and actually experimentally determined with the matter itself. You don't need to do that. And you can change these properties or without necessarily change the atom. For example, you can change the atom's charge or increase its charge. You can change the matter's ductility. You can change the matter's mass. You can change the matter's strength, but not necessarily change the matter that you're talking about. It's still the same element. Well, chemical properties, you can only change those chemical properties if you change the element because they're intrinsic to the element. So chemical properties will only change if you actually have a chemical reaction taking place. So let's do some examples of physical properties. For example, real physical properties. For example, you would have the density, malleability, momentum, mass, charge, color, brittleness, the area it occupies, plasticity, potential, timeliness, velocity, viscosity, volume, so forth. I have a whole list of this on my lecture guide. And you don't need to know the list, but you need to know how to figure out if it's a physical or a chemical property. So if it's a property that can be changed without changing the matter, and it can be observed physically experimentally, it's going to be a physical property. Now, if it's going to be a property that in the act that it only is eminent as this matter reacts with other matter, then it's going to be a chemical property. So in the example that I gave with the couple, the chemistry between them, it's this thing that has to do with how well they work together, how well they talk to each other. It's not about them anymore. It's about the connection between them, or how they relate to each other. So, for example, whether things combust or not, whether things are explosive or not, or whether things are toxic or not, whether things are flammable or not, if they tend to oxidate or not. Do they What's their electronegativity like? What's the valence shell like? What's the radioactivity of it like? What is the reactivity of it like? Those are more like chemical properties. How is this element chemically acting as opposed to actually looking like, or, right? So, like, physical properties are like behavior oriented to the intrinsic things about the molecule, while chemical properties are more like general properties of the molecule. Now, along the same lines, you have the idea of physical versus chemical changes. So a physical change is something that will change the physical property. And the chemical change is something that's going to affect the chemical property. So, for example, when you get oxygen and you combine with hydrogen, so you do an experiment and you get hydrogen gas and you combine it with oxygen gas. This is what the space shuttle did to launch back when it was still in operation. A lot of rockets still do it. You basically burn that and you make water vapor, but you no longer have oxygen gas or hydrogen gas. You have a new thing. It's a compound. Now, the chemical properties of hydrogen and of oxygen are no longer present here. This is a compound that has its own chemical structure. So you change the chemical composition of the matter. And in that case, this was a chemical change. Examples of that would be things like rusting, combustion, chemical reactions, burning something, and so forth. Now, in the other sense, the physical changes will be something that has to do with playing with the physical property. For example, increasing the density of the thing, or increasing how shiny it is, making it mixed it with something else, moving it, making it go faster, maybe it goes slower, putting a charge through it, changing its shape, changing its volume. All of these are physical changes. So if you get a pencil and you break it, it's still a pencil. It's just shattered into smaller pieces. So you change what? The size. That's not a chemical characteristic. That's a physical characteristic. So if you change the size, that's a physical change. So if you change a physical property, it was a physical change. If you change the chemical composition of the matter, it's a chemical change. And so look at whether or not there was a chemical change. Is the chemical formula of this matter the same? If it's not, it's a chemical change. If the chemical formula is not the same anymore, it's going to be a chemical change. But if it's a chemical formula, it's still the same, and what you're changing is just the state of the matter, or how it looks like, or something like that. It's a physical change. When you freeze water, when you melt water, it's still water. All you're changing is the state of matter. Physical change. Those are some good examples of what it is to be the two of them. People sometimes teach this wrong, and they say that chemical changes are not reversible. That's not true. On the chemical changes, talked about H2 plus O2 becoming H2O. You can do this equation backwards and split water apart back to what it was before as H2 plus O2. So chemical changes are reversible. And physical changes are not always reversible. Sometimes you break something in half and you can put it back together. Sometimes you mix things together and you can't really separate them apart. What makes the difference, though, is that you did not change the part. For example, when you put something in a mixture, you put salt and water together, it's still salt. It's still water. They're just together. You didn't make it into a new substance. That's why it's a physical change. Okay? And a chemical change will change the new substance, but it doesn't mean it's not necessarily reversible. So don't get caught up with that. So here are some examples of these things we're talking about. For example, when you see a popsicle melting, that's going to be what? A physical change, because you're not changing the chemical, it's just changing its state. It's melting. The same thing is true about when water is boiling. However, when you burn wood, you're actually combusting the wood, and therefore you're changing. It's a chemical reaction that's taking place. Anytime you have a chemical reaction, like the one that's represented in the bottom, where the electrons and elements are going to be switching places between the matter, and you're going to recombine the position of the atoms or transfer electrons from one from the other and form new combinations of atoms, that's going to be a change in the composition of the matter, and therefore it's a chemical change. Now, when you're dissolving something in the water, that's just a physical change. You're not actually changing the chemical composition, you're just mixing them together. You still have the liquid and you still have whatever you put in it separate, even though one is dissolving the other. But it's not changing the composition of each one of them. They're just together in the same place. Now look, for example, on the bottom. That one's a little more confusing, like rust also, because when that happens, you you're changing the actual color. So it seems like it's a physical change, but obviously something chemical happened there because it's being actually degraded by bacteria and stuff. So there's a chemical change that are taking place there. But in this case, there was a physical change because of the chemical change. Because remember, when you change the chemical properties through a chemical reaction, you make a new kind of matter, and therefore you're going to change the color and other kinds of properties. Same way that the wood, after it burns, it becomes black as it becomes a different kind of molecule. And so that's why it's so easy to confuse chemical changes with physical changes. Lots of times chemical changes will cause physical changes, but in essence it's a chemical change because it changed the composition or organization of the atoms in the matter. While physical changes will only change the state or something about the particle, but it's still the same chemical compound. I hope that helps clarify it for you guys. Alright, in the next video we're going to talk about atoms and elements. Alright, so we'll see you guys then.